we have the famous fractal snowflake, right? Cox snowflake. So we start with one equilateral triangle, and every time you break what? The next stage you break one side, you add a little corner like this.
Yes, you divide each side in 3 equal parts.
Right?
Yeah.
And in the next one, this is not there anymore. Right?
Yes. You'll have little green parts appearing. So,
right?
I can start drawing them, but with more stages,
Yeah.
the number of them increases very fast.
Right. So how many edges are there? Well, we know at the beginning there are 3. Right? The first stage. The beginning.
And the length of each edge is 1.
Is 1. Let's make a table.
And perimeter is 3.
Perimeter is 3. Next time, how many? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Why do I count 1, 2, 3, 4? Do you know why?
Because you look at each edge, what happens to it. If you look at one edge, instead of 1, you got 4 parts.
You break the middle one, you add a little 2, right? So 3 times 4, 3 times 4 square, and then so on. That makes sense?
Yes.
Right? Good. The length. Length is also not difficult, right? What do you guys think? Because at the beginning it's 1. The next time you break into 1/3, so of course it's 1/3. Each one of them.
Yes.
Right? And then that's the red one. And then the green one is 1/3 of the what? The red one. So 1/3 square. And then so on.
Yes, and what's important, we write them as not as numbers, right? But something that looks like a geometric series.
Right.
Well, the perimeter is clear now, right?
Yes.
Because the perimeter is number of the edges times the length of the edge.
Exactly. Perimeter is the product of these numbers column, right? So 4, and here it's 3 times 4/3 squared, and then 3 times 4/3 cubed, and then so on. So, do we always increase the perimeter?
Well, it looks like yes.
Yes.
Every time it increases.
Because it's 4/3 to the power, right? So this number, if I have many stages, the perimeter is going to what?
Infinity.
Yeah. Infinity. Right? So it's like a figure have just infinity many little teeth coming out. So it becomes very long, right? But the interesting question is, does it have a what?
Infinite area. Or definite or infinite.
Yeah.
What is the area of this figure?
I'm not asking you the area of the finger, I'm just asking, does it have a finite area first? Right? To actually find the infinite area, we can do geometric series. That's what we learned from prior courses, right? We can do. But before we answer that, do you have a hunch? Does it have a finite area or not? What do you think?
Well, to me, I think I can create a box here or a circle.
Yeah.
And all these transformations will happen inside this circle.
Yeah.
So my area cannot be bigger than that.
It seems like you are adding pieces that are so small and don't go out, right? So sometimes students try to bound this by what? The hexagon. And then the computation start actually becomes tedious to show why it all lies in there. Then they almost doing the next question, find the actual areas, right? But I think the idea of you are talking about using the circle is a much better one. If you use the idea of the circle, you can prove this without going through any computation. Okay, can you guys give me a good reason why circle is very, very helpful here? The idea is to really understand what does this so-called fractal means. It's actually, if you zoom in anywhere, the picture is basically the same. So for example, if I look at here, this part is basically the same as what? This part.
Or you just said this part is the same, this red and green is the same as big blue.
Right. And that's why the circle helps so much, because this is my circle, right? The key is whenever I build a new stage, this is the interior what? Tangent circle. So that means what? No matter where I look at, the new things is actually always built inside. It never goes out. It is inscribed in this what? Interiorly tangent circle. So that's why if I draw this circle, nothing goes out.
Yes. If you show that the first, let's say, blue circle is tangent to the big red
from interior, then this happens everywhere. So they only goes what? Inside. When they build a new thing, they only build new things within this what? Circle. So this answers this question. So finite. So now we have had a figure that is very interesting. It has an infinite what? Perimeter, but a finite what? Area. So now we did this problem conceptually to understand this, and we did some simple computation to understand why this is clearly related to what? Geometric series, because the whole shape is repeating itself, right? So we also find out how to prove this without a computation, but we still want to know what is the actual area. So that relates to geometric series. So now for you is to do this in homework and then check back with us how to complete find the actual area. Okay.